Hello everyone, this is Leslie Pelch at the Vermont Center for Geographic Information. I want to welcome you to our webinar today, Getting Started with Python. Before I hand things over to Ivan Brown, our actual presenter, I'm going to do a very brief intro to make sure we're all on the same page as far as how to use the GoToWebinar interface. So, I want to start out by pointing out that you should have at the very least a little box on your screen with an orange arrow, and if you click on that orange arrow it will open up your panel if it isn't already open, and you should see a variety of different sections within your panel. The most important of which, if your audio is not currently working, is to open your audio panel, and once you have done that, every time I start my webinar this doesn't work, you can change your audio setup in order to make sure that it's pointing at either mic and speakers or telephone. You also can check, if you need to use a telephone, you can check for the phone number. Notice that the phone number to use is the one that's actually in your panel, not the one that I could show here if I could move my PowerPoint along. So make sure your audio is all set, and if it's not, go ahead and change your setup. The other thing I want to point out is that at any time during the webinar you can submit text questions using your question box. Just type those in, and those will actually come to, they'll come to both of us, because I'm going to make Ivan an organizer as well. So he'll see them, but because you're sending in text messages, you don't have to worry about interrupting. He can save them till the end, and we will plan to do that. We'll save 10-15 minutes at the end of the hour to address questions. The other thing I wanted to point out is, or actually it's more for my own reassurance, if everybody could look for this little button that looks kind of like an orange hand with a green arrow on it, and if you go ahead and click on that, that is a way of raising your hand and just letting me know that you can hear me. So the more of those I see in the list here, the more reassured I am that you can all hear me. Great. And I will check my email in a moment to see if anybody has any problems that I can respond to and help with. And then the final thing I want to point out is that the webinar is being recorded, and we will post it at VCGI's YouTube page within a few days. Probably not by the end of the week, to be honest, but early next week I should get a chance to do that. And there will be links from our website. Maybe I'll very quickly show you that. So at our website we have an event archive. So if you click on events, you'll see this event archive option, and listed there you see webinars. And so this is one way. This just takes you to our YouTube channel. If there are any accompanying PowerPoints or anything, I can also post those here. Another way to get here is simply on our front page. There's a link to all different kinds of ways to connect with us down the lower left, and the last one listed there is YouTube. And you will see all the videos that we have posted there. So there's our YouTube channel. Okay, I think that's all I wanted to point out. I'm going to pass you over to Ivan Brown, Senior Project Manager here at VCGI, and he will be doing the webinar today on Python. So I'm going to hand it over to you, Ivan, and then I'm going to make you an organizer.
Okay, great. Thank you, Leslie.
You're welcome.
Brown. I've been with VCGI for a little over a year now. I have 15 years of experience with GIS. Much of that experience is in the programming area. I have been programming with Python for GIS since 2005. Today I'm going to provide a very general description of the Python programming language, a very high-pass look at it, and demonstrate some very basic Python coding and show you how to use Python within the context of ArcGIS technology. Again, this will be very basic, and it will help support someone who wants to get started with Python, whether you have never programmed with a programming language before, or maybe you have programmed with something else in GIS and want to start to expand your skill set into the area of Python. Leslie, were we going to do a poll?
Yes, I can do that right now. So I'm going to click on turning this poll on, and you're all going to see a question. You can just answer that, and we will get the results from that immediately.
Are we ready to poll?
Yes, actually, I think you should see it. Does everybody, do you see it, Ivan?
Okay, great. Yes, that's coming through.
Okay, and so Ivan, do you see the results as well?
Yes, I see that the majority of our attendees have not experienced with Python before. Great. That means that many, if not most or all, are in the right place here. So again, we just have 1 hour budgeted for this, and it's not going to be a complete Python course. It's not going to be a complete Python for ArcGIS course. Doing that sort of thing would take much longer than 1 hour. This just helps get you started. This is going to be very entry-level content. So, why are we here to do this? Well, let's get right down to it. Python can be used as a tool to support many tasks in ArcGIS and elsewhere in IT work. You can use Python to conduct data processing, for example, run data exports or execute field calculations on tables, feature classes, etc. You can also use Python with ArcGIS to automate map production. For example, you might have a folder that contains an array of MXD files. It is possible to write a little short Python script that can go to each of those MXD files and generate a new PDF, and that could come in handy if you have MXDs that are pointing to various sets of dynamic data that changes, and you can get up-to-date static maps out of that process. You can also use Python to run just about any component of Esri's geoprocessing framework. You can string together a sequence of geoprocessing tasks into a script and let the script run and do the work and perhaps produce some dynamic analytics from geoprocessing tasks such as buffers, clips, unions, etc. You can script out spatial analysis. You can write a script that will analyze a table row by row, conduct analysis on each record, and write a report. You can write a script and then schedule it to run at a particular time. If you're using Windows, you can use Tasker to do that, so you can schedule work to be done overnight. Python also comes with an email functionality, which can even allow you to send an email to yourself or to a list of people when a particular script is done executing. Or you can use the email functionality to send out an email when the script encounters an error condition or fails. As I go through the presentation, feel free to enter your questions into the question box, and we will collect those and leave the last 10 or 15 minutes of the webinar for responding to those. I will answer as many questions as time allows. The last slide of the PowerPoint does have my contact information. Please feel free to take down that information and contact me for additional questions, and I will address those. Python is free. It's open source programming software and programming language. Open source means that, again, it's free. You can download it. You can do whatever you want with it. You can produce software with it and sell your software. It was started back in 1991 by a fellow named Guido van Rossum. He is from the Netherlands. Many think that it was named after a snake. However, it was actually named after the British sitcom Monty Python's Flying Circus, which came out in the late 1960s. And by the way, I've heard that there is a new generation of that sitcom coming out. And Python has widespread use. It's used in a lot of systems that are out there. It's very versatile. It can run on Windows. It can run on Linux, Unix. It's very easy to use. Unlike other programming languages, it doesn't require a lot of use of special characters such as curly brackets. It's actually a programming language that's close to the language that we speak when we speak English day to day. Very close to English. It's one of the best things that has happened to programming, in my opinion, and also it's done a lot of good for GIS. Next slide. So again, it's an excellent beginner's language. If you have never programmed with a language before, Python is a great place to start. You can download it from python.org and install it on your computer and play around with it. It also comes out of the box with the ArcGIS for desktop installation and ArcGIS for server as well. Out of the box, you also get an IDE called IDLE. Now, an IDE is like a workbench. It means Integrated Development Environment. And it's the workbench that you use to write scripts and run scripts, test scripts, etc. You don't have to use IDLE to work with Python. However, I do, and these demonstrations use IDLE. Python is both a procedural language and an object-oriented language. If you've never programmed before, this slide might start to look a little intimidating. However, you can just take a nice deep breath and relax, and I assure you that I'm going to spell this out really easily. I'm going to explain the difference here. So a procedural programming language executes code line by line. It's a very straightforward, very linear approach to programming. I'm going to demonstrate some procedural code here. I'll open up a Python script and show you. This is a very simple script. So we have a file here. It's a simple text file. This is a Python script. We have just a few lines of code here. So when the script executes, Python simply reads this line by line, top to bottom. That's procedural programming. Very basic stuff here. It simply executes a procedure. So let's take a look at what is going on here. So these lines that begin with the pound sign are commented lines. That means that the Python interpreter ignores them when it runs. This is for our benefit. These are used to show us what the script is doing. So we have a little short script here that simply takes a given integer, 76,230, and sets it to a variable, and we call it S. And then we move on to run a function on S that Python gives you a function that makes this conversion from one data type to another. We're going to the float data type here. We'll execute that function and save the result to a new variable called s_flt. We're going to take sflt and divide it by 43,560 and save the output of that operation to a variable we will call a. Down here, we will convert A into a string data type. So we're going from float to string. We are saving the output of that to a new variable called A_str. And finally, we are going to print our final output to the screen with the print command, which you will use a lot if you get into Python. So here we are simply taking the value that is stored by this variable and appending to it this string here so that it's going to print out 1.5 acres or 2.5 acres. To run one of these script files, you simply go to the Run menu and click on Run Module. It's going to run, and there you go. It took our input up here, started here, 76,230 square feet, carried that value through this procedural or very linear process top to bottom, and printed the output to us. Now I'll demonstrate some object-oriented programming. So before we even open up any code that deals with or uses an object-oriented approach, let's step out of programming for a minute and get an understanding of the concept. So if we have an object, we have a car, what are some of the characteristics of that car? And I'm talking about nouns and adjectives as opposed to things that the car can do. A car will have a certain color characteristic, so that would be a property of the car object. It is an object that has objects within itself, such as the wheels. So each wheel would be an object within the car object. Then each wheel will have some properties such as the type of tire. Other properties might include something such as sunroof. Does it have a sunroof? Yes or no? Is it a convertible? Yes or no? Methods of the car mean what can it do? You can put it into gear, you can go forward, you can put it into reverse, move it backward, you can steer. So now that we have looked at this at the highest level, I'm going to show you a script that takes that concept into some programming-like syntax. I'm going to open up this little script here that would fail if I were to run it because this is fake code. This is just something that illustrates the concept that I just explained. So at the top of this script here, we're running an import, and we're importing something called car factory. So when you do an import, you're importing this big bundle of blueprints, little bundles of computer code that can do things. You get access to all of these bundles of code that are in a library. So in this example, we're importing a library of object blueprints, which are those bundles of code that can do things. So at a car factory, the blueprints or components to it might be the labor, the materials, the equipment, and etc. So we're running an import here, and we're getting the whole thing. Once we import the car factory, we can do whatever a car factory allows us to do. So if we move down the script a little bit, we see that we're taking this car factory and we're running a method, the make new car method. So the car factory is the object that has all of the objects executing an available method, make new car. We're telling it we want a Mercedes, and the output of that generates this, my new car, and it's stored in a variable. So now that I have my car, I can set the color to it. So here we have an object, my car. It's been instantiated. Up here we started out as just a blueprint of what a car could be. Now we actually have some running code here. So this line of code would set the color property to white. And maybe I want a sunroof, so we set this Boolean sunroof property to true. So these are property settings here. Now we want the car to do something. So this line of code here shows that the object has a select gear method. So we're executing that and we're telling the car to go into drive. Now I will show you a script that has real code that does something very similar. However, it's actually executable code and does something with GIS. So this script here at the top, it does an import, and it imports something called ArcPy, which you will see all the time if you get into using Python with ArcGIS. ArcPy gives you the whole ArcGIS geoprocessing library. Once you import the library of blueprints, such as maps and tools and properties of maps, such as the source path, etc., once you import all of those blueprints, you can make them come alive. So here we import ArcPy, and then we move on to set a property to ArcPy. So if you think about the geoprocessing framework in ArcGIS, you know that it has an array of environment settings with it that you can set through ArcToolbox. So that's represented here in this env property. So we start with the whole thing, ArcPy, and we go into the environment settings object, which in turn has a property called workspace, which we can use to read the current workspace setting, or we can set the workspace setting. We're setting it here. So this line of code simply sets our workspace to this path, a file geodatabase that I have on my C drive. Then we move on to do something with ArcPy. We're going to run this method here called delete_management. Where did that come from? I'll show you. You can go into ArcToolbox and find a tool that you want to script. Here's delete. You can right-click on one of these tools and go into its help documentation. This documentation applies not only to running the tool within ArcGIS Desktop, but also within a script. It's worth taking the time to read this information here at the top of the document. It explains a lot of how the tool works and what you need in order to be successful with it, how to use it. There's a section here called syntax, and that's the area that you go to in order to determine how to format this method, this ArcPy method, in order to get it to run. So simply put, this delete tool will delete just about any type of data set on disk, and I won't read this out to you. The point is you can read through this to find out what the delete tool does and then go to the syntax. Find out how to format the method. So it's taking two arguments. The first argument is the input data that's going to be deleted. And then we have an optional argument here as a second argument. So you reference this and then you can go back to the script that you're composing and format your line of code. So here in this line of code we're telling Python to take the ArcPy library and run a delete on this feature class right here. Every programming language has some type of handling that's similar to if then do this, if that do that, if the other do the other. It's the classic if-else handling. It's a way to branch out your code into two different directions based on a particular condition. Every programming language has a way of handling loops, and that a loop is a way to execute the same block of code over and over and over again until a certain condition is met. So for those of you who are familiar with some type of programming language already, I will tell you that with Python, it's simple. There are no curly brackets or special characters involved. You can simply format it this way. If something evaluates to true, colon, and then you indent, do this line, do that line. So what this means is if this evaluates to true, it's going to execute this block of code here, not this block of code. So if this statement were to evaluate to false, these lines of code would be skipped and Python would jump over to the else, which is like, it means otherwise do these things. For a loop, and again, there are no curly brackets, nothing special here required. Indenting is what Python uses to make these blocks of code. For a loop, it goes like this. While something evaluates to true, then you have your colon to signal that we are starting a block of code. Do these lines of code. Then below this you might have some other lines of code that move over to this level here so that it will resume after you go through the loop. And I'm going to demonstrate some if-else and some looping. And I'm having a hard time getting back to Windows. There. Thank you. All right, an if-else example. So I have this script here that imports a module or library out of the box from Python called random. Random is a module that can be used to generate random numbers. So in this script we import random, and then we're going to use random's randarrange function to generate a random number between 1 and 1,000. And we're going to store the result of that with this variable here, mynum. Then we're going to print something about it here. It's going to say randarrange gave me this. And it has to convert my number to a string because the print operation prefers strings. Otherwise, you can get an error. So we have our random number generated, and then we're going to run that through this if-else handler here. So when the script gets to this level, it's going to evaluate mynum. So I have it set up so that if the number is less than 400, execute these lines of code. And now here's an elif. That means if this is true, do these. Else if this expression evaluates to true, if the random number is greater than or equal to 400 and less than 600, then do these. Here's another elif. And here's your final else. So if these statements here, none of these evaluate to true, then this block of code is going to occur. I'm going to roll the dice and run this. Let's see what happens. So it generated random number of 853, and it printed this information to us. And that is indeed true. It is greater than or equal to 800. So what happened is 853 was generated here, and then variables carried into this if-else area here. And given that 853 did not fit into any of these evaluations, this block of code executed. I will demonstrate a loop. So again, with this script, we are importing the random module, and we want random to generate. We want to see how many times random runs with random's going to generate a number between 0 and 999. We want to see how many times it has to run in order to generate 382. So I set a variable here which will store random numbers as they are generated, and I initially set it to -1. It's just a placeholder for that variable. I make a variable here called counter to count the number of loops that are run until we get our desired number. And here's our loop. So it goes like this. While this expression evaluates to true, colon, do what's in this block here. So with each loop or each lap around, it's going to set our random num variable to a random number between 0 and 999. It's going to print the result of that. It's going to update my counter variable to count the laps around through the loop. And here's an if, and there is no else. It just simply says when random number is equal to our goal number, or 382, do this block. And at that point, when random num does equal to 382, this will evaluate to false, and this loop here will stop executing. So I'm going to run it. And it's generating numbers until, and eventually, I promise, it's going to generate our desired number. Okay, after 2,438 random tries at generating a random number of 382, it worked out. I had to generate a lot of random numbers to get to that point. So at this point, the while loop stopped and the script completed. Okay. So this is going to be a slight review. So again, when you import a module with the import statement in Python, it's like importing an object or an object that contains objects. So you get the car, which has wheels, which has a glove box, which has a gear shift. With ArcGIS, you import ArcPy, which gives you the whole workshop, all the tools that you get out of ArcToolbox, and even some things that aren't in the ArcToolbox, such as MXDs. And the second bullet here in the middle is really review. And so again, we import ArcPy to get the whole array of tools. And this little graphic down here on the bottom of the slide shows us how we can import ArcPy, go to ArcGIS's environment settings and set the overwrite output environment setting to false. And again, I think this little spotlight thing has frozen my computer a little bit. Okay. All right, back on track. So, saving and running scripts. A Python script has the file extension .py, and you can, if you're using Windows, at least you can, if you install Python out of the box or with ArcGIS and don't alter a whole lot of settings, it will set up so that you can right-click on a Python file in Windows and open it in idle, which I will demonstrate. I don't think I'm going to use a spotlight anymore with these things. That's embarrassing. All right. Boy. So I'm going to just simply open up idle straight up without any script. So you can find it if you go to ArcGIS in your programs area, and then you'll see a subfolder for Python, and here's idle. I'm going to open it up. So there you go. When you do that, you simply get the shell, and this is interactive. You can issue a command here, and it will execute immediately. To open a Python file, one way to do it is to use the File menu, and I'm going to open up one of these. A very short script here. So when you do that, you get a new window for editing your script. So we aren't interactive in this window. Here's the shell where the code runs, and you can see what you get from the script. I'm going to modify this file a little bit. Save it. And to run it, it's run, and then run module. And there you go. It ran in the shell. Okay, I'm going to demonstrate, and I've actually done this several times already. You can right-click one of these files and edit with idle, and it will open up in idle, and then you can run. You can also simply double-click the Py file, and it will run through your command prompt. Now, again, this is how it looks in Windows. And I'll hit enter, and the black box will go away. All right. Okay. Some best practices for Python coding, and really with any programming languages. With any programming language, again, it's important to insert comments into code to help illustrate what the code is doing. It makes it easier to work on the code and make modifications to it. I'm going to explain what pseudocode is. That's also very important. So I'm going to explain that by opening up this script right here. So here's a very lengthy Python script that I use to add certain fields to a layer, calculate some fields, and delete some fields. The point of this is I have comments sprinkled throughout my code. Again, these lines that begin with pound are comments that explain what is happening. I'm adding fields. Now I'm done with that. Here I'm calculating fields. Pseudocode is code that's English level code. So it's good to write out in English or Spanish or whatever you prefer. What do you want the script to do before you actually go to code it? Now, this is a very simple example of that. And have my pseudocode of this script commented out into the top area of the script. As another example of pseudocode, this is a script that exports or reprojects feature classes to the Web Mercator auxiliary sphere projection. I simply wrote some pseudocode before I wrote the actual code that laid out what I want the script to do, and then I wrote all of this. Script headers are very helpful. So in this example, I have an area commented at the top to explain what the script does. This history section keeps a record of who worked on the script and why over time. That can be good institutional knowledge. You're free to add as many notes up here as you want. You can include some information on how to set variables and run the script. And again, here is a section for pseudocode. Another best practice is organizing your scripts in a certain way. So if you have scripts that you want to share out to your organization, it's good to have a shared drive where you store them. What I like to do is have a designated place on a shared drive where I put stable scripts. So these are scripts that have been debugged, they're tried and true, dependable. I can go to the shelf, take one from there, and run it. And I know that it's stable software. I can have a separate area for developing scripts. And then when they are developed and debugged and they are all good to go, they can be moved to the stable folder. And I like to keep a separate folder for each script. It keeps things organized. Sometimes a script requires more than one file. That's a little bit more advanced. For example, there might be an initialization file that sets certain parameters. We can't go there in just an hour. Another best practice is using try and except to block out your code so that error conditions can be handled a certain way. So here we start with try, and that means this whole block of code here after the first indentation gets executed. And if anything goes wrong in this block of code here, if the script has to bail out because it trips up on something, then script in this block of code in this block of the script executes within the except area. So that can be really helpful when debugging your script, or even if it's a stable script and the stable script encounters something like data that's not there that the script expects to be there. Very helpful and highly recommended. Again, Python installs with ArcGIS out of the box, and the version of Python that you get is not necessarily the latest version of Python. And I like to use the particular version of Python that Esri installs when I'm using it with ArcGIS. It's common sense. Why use an older version with ArcGIS 10.1 if 10.1 is going to support 2.7.2 in particular? So again, I'm going to run another demonstration for you. I'm going to run that script that adds fields, calculates fields, and deletes fields. I'll open it back up again. It's this one. So I'm just going to go to the essence of this thing and show you what this script is doing. So I wanted to add a field. Where did this come from, all this stuff? And what happened is I looked up in Arc Catalog Help information on the add field method. And this explains the tool and what it's all about. And here's the scripting syntax. So I read all of this. Here's how you format your line of code, and it has a lot of arguments for adding a field. You can even set a particular domain to a field. Some of these are optional arguments. So I spent some time there, and I did the same thing for the calculate field tool. I read about it and got the script syntax and reflected that here in my script. So we're adding a couple of fields here, calculating a particular column here, and here we are deleting some fields. Now this is a a tool that will delete a list of fields. And I don't have time to tell you about Python lists. I just need to let you know that you need to make one to include all the fields you want to delete and then feed it here. And if you read the tool help, you will see that you need to do that. And that's actually not that tough. So let's run this thing real quick. It's importing the modules. It's encountered the line of code where the workspace is set. Now it's actually adding those fields, running the calculation. I think the calculation was to set all rows of a particular, yes, this field gets calculated to 1 for the roads feature class. What's it doing now? Okay, so it did all of that work for me. Now it's completed. Cursors are very powerful. I don't have time to make you a cursor expert. However, you can search ArcGIS Desktop's help for these methods off of ArcPy. Search cursor will allow you to, and it's not a blinking cursor, it's something that will go through a table and read each row of that table line by line. You can script it out so that the script does something with each row. An update cursor can actually go through all of the rows of a table and update them and calculate a particular field and even do so dynamically. And then an insert cursor adds rows to a table or feature class. I have a sample of that I'm going to run for you. It's this one here. And this script simply, okay, again, we're importing ArcPy, we're setting our workspace to the geodatabase that we want to work with. And here's where the good stuff starts to happen. We go to ArcPy, we run the search cursor method, and it requires some arguments. And you can find these in help. So the first argument is the feature class, and then the second argument is an optional where clause that will cause only certain records to be returned to this search cursor. So we're only going to go through the table of the roads feature class and get the rows that satisfy this query right here, roads that have the name Memorial Drive. And we are going to move on to create a text file object. And here's the syntax in Python for doing that. We're going to create an empty new text file on disk. We're going to run this next method on the search cursor object to get the first row. And then we're going to go to a loop. So while a row is something or evaluates to true, we have a row. We're going to set a variable called the town to equal the value of this particular field. And then we're going to write that result, or the value of that variable, into the text file by running this object and method here. And then we're going to get a new row, the next row in the selection set. And when the loop gets to the point where this is nothing because there are no more rows, then this no longer evaluates to true. At that point, Python will say, I'm done with the loop. Let's move on. So the script will then move on and close the text file. You'll have your text file on disk, and your report will be ready. I'm going to run this. So again, it's going to write into a text file all streets that have a record with a town name of Memorial Drive. Or it's going to write the town names of all towns that have a Memorial Drive per the roads layer. So it printed all of these out to the screen for me. So St. Johnsbury has a lot of Memorial Drives, so does Montpelier. I'll go to disk and find my file, and here it is. You could do something more sophisticated with that and have the redundant entries removed. Again, this is just an illustration, a high-pass look at the power of cursors. And we're running low on time. I have, I think, just a couple of slides left. So, again, ArcPy library gives you the whole thing. And then there's there's an area of the library called mapping that exposes you to some really powerful methods for doing work with MXDs. So I'm going to show you how to run the export to PDF method that will take a particular MXD and write a PDF export from it. So here again we import ArcPy. We make a map object by going through the mapping objects map document method, which you can read about, and we do this because this export to PDF method requires this type of object. So we're going to export to PDF, and again this method requires a map and a path to the output PDF. I'm going to run this. It's making the object that the method needs. Now it's actually exporting the PDF. Here is the MXD that it exported from, a simple town map. I'll go to disk. Here's my export. And what else do we have here? You can also run a script as an Arc Toolbox tool from within our catalog. You can also export a model that you build with a model builder to a script. And we don't have enough time to get deep into those. However, I can show you that I have a custom toolbox here that I made, and you can read documentation on how to make a script tool. Here's a script that I can run as a tool. So I'll double click that. I won't run it though because we are running low on time. And there are some special things that you need to do in order to feed these parameters into your script. These input controls are setting variables in a similar way to how we set variables in those scripts that I demonstrated. You can also make a model and then go through the model menu and export your model to a Python script. This will generate a Python file that you can then open up and idle and modify. And again, I don't have time to do much with that. I just want you to know that it's possible, and you can look into that if you want to leverage that functionality. Leslie, I am sure some questions accumulated during the webinar, and I would be happy to take a look at those if I can get back to my GoToMeeting bar. Okay, I'm going to bring that back out and take a look at this. Okay, questions. Or did you want to read those questions to me, Leslie? How do we do this?
Well, if you can see them, you can go ahead and read them out loud. Do you have them there?
Okay, I can't see them very well. Okay, so I have to click one.
You can actually pull that whole part of the panel out into the center of your screen and make it bigger so that it's a little bit easier to read. You can kind of grab the bar where it says questions and just pull that right out.
Mine's not coming out. Maybe you can read them.
Yeah, I can just read it. Okay, so one question is, oh, and I'll just mention for anyone that missed it early on, one of the questions was, will the slideshow be available for download? And I just wanted to let everyone know I will indeed post that, the slideshow that Ivan's using at the event archive page at our website. So the first question is, what did the exclamation point represent in the random number loop example, which was earlier on?
I believe that was just something cute that I typed into the script to print some. I think I wanted to see some exclamation marks.
Okay, so
I think I was just trying to show some lines of code executing as opposed to showing any complicated lines of code. So a simple print is it's really easy to see.
Okay. And then Emily asks, I know you may cover this in later slides, but do you have recommendations of any good resources or tutorials for those of us who want to learn more?
Yes, there is a lot of good information on using Python with ArcGIS out, actually Python in general. There's a lot of information out there. You can go to python.org and find Python tutorials and the full Python documentation. And if you find a tutorial and it doesn't resonate with you, then go find another one, because again, there are a lot of them out there. You can search the web for those. They're easy to find. Most of them are free. And then Esri has a Python area in their resources page on their website, which links to resources for learning more about Python, and they even have some training, some webinars that are, some of them are free, that get you started with Python, and some of them cost a few dollars, and then you can even pay a little bit more to get deeper into Python.
And that's all I see for questions. If people have questions, this is the time to send them.
Well, given that we have now a surplus of 4 minutes, I will go back really quick to this slide that I thought I might have to skip over. Some real-world uses of Python. I'll tell you about these. One was a reverse 911 system that received flat files from the phone company for updating a geodatabase, which in turn was used to execute reverse 911 calls by spatially selecting address points. So Python was used to make an array of scripts that read those raw flat files from the phone company and update the geodatabase which the reverse 911 system used. This Python and ArcGIS can be used to automate ArcSDE geodatabase administration. Again, if there's an ArcToolbox tool, then it can be scripted. So routine maintenance like compression can be automated that way. And again, you can even set these up as scheduled tasks to run after hours automatically for you. It can be used to go through a data set like a street centerlines data set row by row and look for things that don't make sense as part of a QC check. For example, you might want a script that looks for address ranges that go the wrong way. Or maybe there's an odd range on both sides of a segment, and perhaps that's something that should be looked into. You can also copy data. I've used it to copy data from an ArcSDE geodatabase to a file geodatabase as a periodic scheduled task. You can script out spatial analysis with this. I have written a script that takes a polygon layer of reporting districts, which were emergency response districts. It took each polygon and identified the district numbers of the adjacent polygons and brought those numbers back into the subject polygon so that a system could go identify a polygon and get the district numbers of the adjacent polygons. And it can even read, if you have software running on a server that writes out log files or writes errors to a log file, you can use Python to read that text file or that log file and send you an email if it finds certain errors in there. And that way you get a little notification when something's not looking right. And I've even used it for rebuilding ArcGIS server caches. So, for example, you can set it up so that it starts to rebuild. For each item in a list of caches, it rebuilds the cache and sends you an email when the cache is done. That can make for some interesting over-the-weekend email. So as I was saying that, Leslie, did anything new pop up in the questions area?
Yes. Is the webinar being recorded for posting to YouTube? Yes, it is. So it's going to be there'll be a link from our webpage in the events archive, but it will also, the link will actually just go to the YouTube page, for the recording itself. So yes, it is. That's the only question.
Thanks, Leslie. And here's the last slide with my contact information. Should anyone have additional questions, I would be happy to shed some light on Python.
Great. Thank you very much, Ivan. And thank you, everybody, for participating. As Ivan said, if you have any questions that come up afterwards, feel free to contact him or me. I can pass your questions along to him if you lose his email for some reason. And I think that's all we have time for today, and I think we're all set. So thank you, everybody, for participating. And as I said, if you missed it, this is being recorded, and it will be posted at our YouTube page, and you'll be able to find a link at our web page in the event archive, or if you just look for Vermont Geospatial on YouTube, you'll find our channel. Thank you, everybody, and have a great afternoon. Thanks, Ivan.
You're welcome.